Okay, so I wanted to make this short video in between the main one, just to further clarify a few points. And this is very important. I told you that calculating derivatives by definition is going to be in your exam, and in fact, this may be also something that I might ask for the Thursday mini quiz. So it's a very important thing because I really want you to pay attention to it. You're going to have to compute derivatives by definition. Not just apply a rule, but you're going to be asked, you're going to be given an expression, and you're going to be asked to find the derivative. Or, as in this fifth example, recognize a limit as a derivative of a function at a given point. So how do we proceed here? Well, basically, in this kind of problem, just look at what's up here. So the function that you're going to be differentiating is going to be given from this dependence on x, from the first term in the numerator. So now the point here is how do we find what the point is? And so now you look at the bottom, you get the 3 is going to be the point at which you're differentiating. So for the function, look at the upper left corner, and for the point, look at the bottom right corner. So x is approaching 3, so that's a giveaway that that the derivative is going to be at 3. If instead they give you the limit when h approaches 0, then it's not 0. You're adding something to h. You're adding it to something, and that's going to be your point. Okay, but here the function should be equal to 5 to the x. So this better be f of 3. Remember that here we're using the first expression for the derivative, and so we're subtracting f of x from f of the point 3, which you already know is 3 because of that. And what is f of 3? F of 3 should be 5 to the 3. Remember, we plug what we have here, so 3 in the expression for f of x, so up here. So that gives us 3, and 5 to the third power is equal to 5 times 5 times 5, so 25 times 5, which is 125. So this up here is 5 to the third power. So this is just the limit when x approaches 3 of f of x minus f of 3 divided by x minus 3, where f of x is 5 to the x, right? And this, by definition, the first expression for the derivative gives us that this is equal to f prime at what point? 3. So it's f prime at 3, or 5 to the x prime. In the same way, here we apply the same thing we did before, so this gives us the function. So the function better be f of x equals 3x plus 2 squared. What is the point? 1. X is approaching 1. And then 25 should better be f at 1. So let's check. Is it f at 1? So 3 times 1. Remember, x is takes on the value 1 plus 2 squared. Yes, because this is equal to 5, and 5 squared is equal to 25. Okay, so this is exactly then, just like before, this is going to be equal to f prime at 1, where f is 3x plus 2 squared. Okay, so this is 3x plus 2 squared prime at 1. Same thing here, so this is 5 to the x prime at the value 3. So we're gonna very soon start the thinking of derivatives as functions themselves. Now there's an example where you have a limit not when x is approaching a certain number, but when h is approaching 0. So now figuring out the function is going to be just a little bit harder, but not that much. So the function is going to be given by, again, this expression here. And in this case is square root of x. And the point, well, look at what's inside that function. And you've got 4 plus h, so that's the point. The point A is going to be 4 then. We're adding h, a small number, to the point. Right, so f of 4 plus h is equal to the square root of 4 plus h. We take the square root of what's inside f. And this then better be f evaluated at 4. And that is the case. This is the square root of 4, which is equal to 2. And so now we have something in the second form for the derivative of a function. So this is going to be equal to f prime at 4, right, for the function square root of x. So, and this is just a matter of recognizing. So if that something is the derivative of something, I mean, some expression, some limit is a derivative of something, and this function is actually not unique. If you add any constant to 5 to the x in here, or 3x plus 2 squared, or the square root of x, you're going to obtain that's the derivative of the same function. I mean, we'll see in the next video the derivative of constant functions is 0. So whenever you add something, a constant to a function, it gives you the same derivative. Okay, but for now, yeah, I mean, this is just about recognizing that something is some limit is a derivative. It's a derivative of a known function. And you may be asked in, say, a multiple choice question: is this the derivative of, say, square root of x at 4? And the answer should be yes. Okay. One final thing. And this is just for as introduction for the next video. We can compute the derivative of a function f of x at every point x. This gives us a function. So the notation here for the derivative that we use, well, we'll use 2. So we write the derivative in 2 different ways: f prime of x or dx of f. And when I want to find out the point which I'm evaluating the derivative as a function, in the first case, so f prime evaluating at point A, we simply denote f prime of f prime at A, so that's in the argument, and dx of f at the point A. Okay, so everything we're going to be doing next has to do with viewing f as a function, and from now on, that's all we're going to be doing until the end of the semester. We're going to be deriving rules for differentiating functions and apping. We're going to go over some applications such as finding extrema, the maximum, minimum, and solving optimization problems in the end.